Hello, my name is John Edmondson. This is a presentation of Toolpath Oscillation, one of the new powerful commands that has been added to Alphacam 2013 R1. What is Toolpath Oscillation? It's the vertical movement of the tool whilst cutting. If we look at this simulation, we'll see that while the tool is traversing along the cut, it is also moving up and down in Z. So why oscillate the tool? Well, it helps utilise more of the tool's effective cutting length on hard materials, for example hard metals, on stone, and maybe on solid surface composites. It will also help reduce localised tool wear on laminates and composite panels such as plywood. This will in turn improve the edge finish, and we will get an extended tool life. Oscillation will help give us better tool life, particularly also on plywood. If we look at this panel, this is made up of multiple layers of ply and glue, and the glue is extremely abrasive to the tool. Oscillation can be applied to 2D rough and finish toolpaths, utilise the full tool cutting length on composite panels, including carbon fibre, and also 3D spline polyline toolpaths. This simulation shows a 3D toolpath utilising again the full tool cutting length on a 3D spline or polyline toolpath. From the project manager page, oscillation is easy to apply, easy to edit, and then easy to save as a machining style. Next we'll show how we can add a scalloped edge to a tabletop, starting with a simple 2D finished toolpath. Now this edge detail has been created using a 20mm ball-ended tool with a material top of 0 and a final depth of -5. The -5 is important, we'll come on to that in a moment. So in the operations page we select oscillation, apply oscillation. We'll start with a sine wave, and I'm going to have an approximate pitch of 200, see what that looks like. Now the height, I want the height to be 5 because I'm starting at -5 and I'm coming above that, and a tolerance of 0.1. If we simulate that, it's not quite the scallop I wished for, but what we can see there is it's coming up to Z0 from a position of -5. So we'll come back in here. Again, we'll select oscillation. We're editing this now. Let's see what it looks like with a 50mm. Apply, simulate again. Now one of the clever things is that it automatically lines up the start and the finish point. Now that's achieved because it's an approximate oscillation. Oscillation can also be saved as a style. We'll save this as 20mm ball. The machining style can be further automated by assigning a layer for the geometries. We'll select outlines. Now when we apply that, it just assigns it to the layers outlines and puts the profile on the outside edge only. We can simulate that. There are two oscillation strategies. The first is sine wave, which gives a nice smooth transition. However, that does deliver a lengthy NC code. Some controllers may not be able to take that, or may not have enough speed to be able to oscillate at that speed. An alternative therefore would be the zigzag, which isn't quite as smooth but does deliver a reduced NC code length. Toolpath Oscillation is easy to apply, edit, save and automate. It's ideal for hard metals, plywood and laminates, MFC, melamine based chipboard, carbon fibre panels, stone and solid surface composites. Benefits include reduced tooling costs, improved part quality and added functionality to your machine tool. New in 2013 R1. Thank you for your time.